Hello everyone, welcome back. Today's topic is ANOVA. Today we are going to learn about ANOVA, examples of ANOVA, steps in ANOVA, types in ANOVA, and one-way ANOVA, and pros and cons of ANOVA. So ANOVA or analysis of variance is a statistical method used to compare the means of three or more groups. It is a powerful tool for testing hypotheses whether there is a statistically significant difference between the means of different groups. And it is widely used in varieties of fields including psychology, medicine, education, and business. ANOVA works by partitioning the total variance in a data set into two components: variance between groups, variance within groups. And the limitations of ANOVA would be ANOVA can only tell you whether there is a statistically significant difference between groups. It cannot tell you which groups are different. If ANOVA rejects the null hypothesis, then you will need to conduct further tests to determine which groups are different. Here is an example for ANOVA. A researcher wants to test whether there is a difference in the effectiveness of three different teaching methods for teaching students math. The researcher randomly assigns students to one of the three teaching methods and then measures their math achievement at the end of the semester. The researcher can use ANOVA to compare the math achievement scores of the student in the three different teaching methods. If ANOVA rejects the null hypothesis, then the researcher can conclude that there is a statistically significant difference in the effectiveness of at least two of the teaching methods. Let's see the steps involved in solving ANOVA. The first step would be calculate the mean for each group. And the second step is calculate the total mean, where third step is calculate SSB, where SSB stands for sum of squares between. And the fourth step is calculate the between groups degree of freedom. And the fifth step is calculate SSE, where SSE stands for sum of squares error. And the sixth step is calculate the degrees of freedom of errors. The seventh step is determine the MSB, where MSB stands for mean square between. And the eighth step is determine the MSE, where MSE is mean square error. And the final step is ANOVA test statistic. Coming to types of ANOVA, we have seven different types of ANOVA. The first type of ANOVA is factorial ANOVA, N-way ANOVA, one-way ANOVA, within subjects ANOVA, two-way ANOVA, mixed model ANOVA, and omnibus ANOVA. Let's learn about one-way ANOVA in detail. One-way analysis of variance is used for test of hypothesis that three or more populations have means that are all equal, as in H naught is to mu1 equals mu2 equals mu3 by analyzing sample variance. One-way analysis of variance is used with data categorized with one factor or one treatment. So there is one characteristics used to separate the sample data into the different categories. The F-test, used to compare two variants, can also be used to compare three or more means. This technique is called as analysis of variance or ANOVA. For three groups, the F-test can only show whether or not a difference exists among the three means, not weigh the different lives. The ANOVA test is right-tailed because only large values of test statistics cause us to reject equality of the population means. Other statistical tests, Keefe test and Tukey test, are used to find where the difference exists. Although the t-test is commonly used to compare two means, it should not be used to compare three or more. There is a different F distribution for each different pair of degree of freedom for numerator and denominator. The first is the F distribution is not symmetric, it is skewed right, positively skewed. The values of F distribution cannot be negative. The exact shape of F distribution depends on the two different degrees of freedom. In the F test, two different estimates of the population variance are made. The first estimate is called the between group variance and it involves finding the variance of the means. The second estimate, the within group variance, is made by computing the variance using all the data and is not affected by difference in the means. If there is no difference in the means, the between group variance will be approximately equal to the within group variance, and the F test value will be close to 1, will not reject the null hypothesis. However, when the mean differ significantly, the between group variance will be much larger than the within group variance, and the F test will be significantly greater than 1. Now you should reject the null hypothesis. The following assumptions apply when using F-test to compare three or more means. The populations from which the sample were obtained must be normally or approximately normally distributed. The sample must be independent of each other. The populations have the same variance or standard deviation. The samples are simple random samples of quantitative data. The different samples are from populations that are categorized in only one way. Coming to the part of advantages and disadvantages of ANOVA. Advantages of ANOVA would be quantifies magnitude of classifiable mean effects and interactions. Presence of G cross E, identifying environments as TPE when no significant G cross E is present, and similarity in magnitude of G cross E. Disadvantages of ANOVA model is does not describes the pattern of G and E response, requires replications within environment, quantifies G cross E in single dimension, assumes homogeneity in experimental errors. That's all for today. Thank you for watching my video. If you learned something from this video, don't forget to share, like, and subscribe. Thank you.